Till now in advanced Python we have discussed iterators, right? We have discussed generators. Now we are discussing decorator. So decorator is a bit different. Decorator is a kind of, you can say, function or callable object. Callable object. What its use is, suppose you have created a function, right? Any function, for example, you have created a function for calculating shortest path, right? You are using some discussed try algorithm, you want to calculate shortest path for some food delivery app, right? Food delivery app. If you are doing some writing this function and you want to write some test cases about this, or you want to extend its functionality, then either you do the changes here, or you will use decorator to add functionality before and after this, right? So this is the use case of it. So generally it takes a function, adds some functionality to existing function and returns it. So decorator's main job is to extend the existing functionality. These are mainly used for logging purpose also. If you want to calculate time of a program, then you can also use decorator. Logging means you want to generate your logs, so you can create decorator, and every time instead of writing that code, you just call that decorator. Before calling the function, it will show you all the log information, execution of time and the other things, right, that you will add. Similarly also for authentication purpose, you want to authenticate the user before calling that function, that you can also add the functionality. So if you have written any existing function, if you want to extend its functionality, either you change the code. If you don't want to change the code, then another way is to use the decorator, right? Also the main use case of decorator isn't testing, software testing. There's a module in Python, unit test, which is based on this concept decorator, right? Okay, so we can see this after generally this is used in software engineering, right? But nowadays also asking in data science jobs, because nowadays data science applications are deploying on server, right? So that is why you should know this also. Okay, let's move ahead. I will show you some examples, right? Yeah, as I told you, logging, authorization, performance measurement, it means calculating the execution time, right? Caching purpose you can also use for access control, pre-processing and the post-processing functions. Before executing your function, suppose you have some function, is function name is suppose calculate distance or okay, yeah, let's write calculate distance. If you want to calculate distance between your restaurant, okay, you have a restaurant, okay, and restaurant to your customer address, right? So before and after this you want to do some pre-processing, then you can add via this decorator. How you can add this, let's see now. So decorators are of two types. One is function based and another one is class based. I will show you in upcoming slide. First we are focusing on function based. So function based is very simple. You can see here, this is my actual function that I want to execute. I want to calculate the cube of any number, but I want to add some functionality to it just to showcase to you. So what I am doing is I am creating a decorator here. This is my decorator. You can see this is the name of the decorator is sample decorator. It is taking input of function, right? And inside function it is creating its own function. Generally this is known as wrapper, or you can say inner function. Now in inner function it is printing or doing some operation, like it is printing before function call. Now they are calling the function. Whatever function you will pass here, it will call here and output will be here, and it is printing the output is cube because we will pass this function here. You can see in this function we are passing cube. Now any option that you want to do, you can do here before or any operation that you want to do after, you can do here. We are just printing the message to showcase you. Print function call after function call, right? Before function call and after function call. We are just printing to show you. And at the end, you need to return this function. Return this function, this example function that you created, or wrapper function that you created. You just return this. So what will happen whenever you will call this decorator with this method, it will take this function inside this, execute these things before, after, and in between that it execute this. Right now you will write like this, and then you will call this decorator like this, its name, and you are passing argument that you want a cube of 2, then output will be 8, right? But it is very difficult. It is not difficult way. It is not the way that we use as a developer. The simplest way is to, instead of writing these 2 lines, you can write this. This is the most simplest way. At the rate, in lots of Python code, you have seen above function, you might have seen these kind of at the rate sample decorator or at the rate something. This is the decorator. So what it will does, whenever you call this function, it will first call this decorator and do all the things, and this function will be argument for this decorator. So instead of writing this, you can write here this, then whenever you call function, it will automatically call the decorator with this function argument. So this is also used in Flask. If you see in Flask, if anyone has used Flask for web development, we define here root, right? Root we define at the rate root or something, right? So this is a very good way to extend the functionality. I will show you some example also. So instead of assigning the function call here, just like we were doing, we can also use the at the rate symbol. This is the most used way, right? You can move this to from this to this, right? So that is the most simplest way, right? I know it is difficult for who is seeing it first time. Let me simplify this. You have any function that you have created. For example, we have created this function. We want to add a functionality before its execution and after its execution. So for that we are creating the decorator, and decorator will have function inside function, and it will take function as an argument. You don't want to write in this way, then you can use the at the rate symbol, right? Let me show you another example. Okay, I will show you example. Just don't mind about this. After this, when we will do code, I will show you the details about this, right? Now there is another way. If you want to create a decorator, another way is to create via class. Till now we have created via function. So also you can create via class, but generally I have not seen people are using the classes. I have not seen much. I have seen most of the data science application are using the function, but you can also use this. In this case, you have to use a method call. Just like in iterator we were using one method which name underscore next. Here we are using underscore call. This call will have the whole logic that you are writing there in function. It has the same logic, and you will pass this output instead of passing the function. And this is inside this class cube decorator, and you also will have init, means constructor, right? Constructor will take the function. Now whenever you define your function, you will write at the rate cube decorator. Now cube decorator is a class. Now whenever you call this, it will call this decorator, and this function will be input. So first it will execute this, then it will call the function, then it will execute the remaining part. So this is after, this is before. Now here we are passing these. This is known as variable length argument, and this is known as keyword argument, right? Okay, this is positional and this is your based on keywords. So it means whatever argument you pass, it will take those argument, like in our case it is now. So you can create same decorator via also class. So you need to define your logic or the functionality here, or in function you need to define function inside function, right? That's how you can define this. Okay, now let me show you one real life use case, right? A real life use case. Yeah, so how this works: call method underscore call underscore method. It is invoked when decorated function is called. It wraps function execution by adding extra functionality before and after, because you can't change the original function. Original q function, suppose it is taking input x and returning xq, right? You can't change this function. You are just adding functionality here before and after, right? Here before and after. So in that way it is useful. So it prints before execution, calls the function and print q value, then prints after execution, right? Just like we are doing. It will call the function, print the value, right? It is before, it is after, right? That is what it is explaining here. Now we have created decorator using class and function. Now let me show you one real life use case, right? Otherwise you don't understand it. Now the real life is, suppose you want to execute, if you want to calculate the execution time. Suppose you have created one algorithm for algorithm, maybe your algorithm is Discustra algorithm, right? You want to calculate the shortest path, Discustra shortest path, right? Now you want to see how much time it is taking, right? This is your function, right? To execute, you want to calculate its time. So what I did is I created execution time decorator. It has one wrapper. Generally we create a wrapper function. So it will take these arguments, and this is your original function, which is this, in our case which is this, but I am giving you example of this. So instead of this, you can write your call your this function here. Now it will calculate the start time, then it will calculate the end time here. This is your end time, and it will do minus with this t, and this will give you execution time. Now every time if you write this execution time at the rate execution time, whenever you will call this function, it will automatically call the decorator, and when it will call the decorator, it will also give you the execution time. So it means if you create a decorator, then your execution time is always sorted. You just need to use this. So this will be very easier way to calculate the time instead of. So now if you create any of the function, for example you are calling it, you are writing a Discustra, you just need to write at the rate execution time, right? Execution time, right? Okay, now whenever you call this Discustra function, right? Discustra underscore shortest path, right? Shortest path function, whenever you call this, it will calculate its time, and at the end it will print this function execution time, right? So this decorator can be used at multiple places with each and every function. So instead of writing every time this, you just need to create a decorator and just add with at the rate. So similarly you can also do authentication. Similarly you can also do the logging of the execution, and many other applications that you can use there. Generally I have seen into use of this into Flask, Django, web application, and software testing. If you do testing in Python, these decorators are very useful. Okay, now that's it. Now let me summarize all of that, what you have learned, right? We know iterator is generating item one by one using next, right? it extended this and simplified this via yield in generator, right? It saves memory, it also saves memory compared to the list. Both generate sequence, right? Okay, and generate sequence of course, but it suspend the execution, resume later for next iteration, right? But in list or function it will return the whole result, right? Now see the decorator modifying the behavior, existing behavior. No major impact, memory doesn't impact much. Apply to a function permanently. Whenever you call the function, it will always call. Okay, control flow execute at function call. It executes wherever you call this function here, it will execute that decorator, right? So decorators perspective or objective is to modify the existing behavior or add some functionality. It can be logging, it can be execution time, it can be testing, right? It can be any other thing, right? Authorization. Okay, all these things you can do here, right? Now let me show you with the help of example, then I will take your doubts, don't worry. Okay, now decorator, right? I need to create one any decorator, any simple decorator, so that we can see how we can implement this. So there are two ways. Generally I have seen people uses the function way. I have seen this, right? So how can we try this? Let's create one function, right? Def. So suppose I am creating a sample generator or any generator demo, right? Generator demo, right? This is my demo method, right? Okay, it will take argument function always, any function. So you can give any name. I am giving function because it should be easier to recognize, right? And it will always have a function. Generally if you see most of the example, say it is a wrapper, it is a wrapper, right? So if you are creating a wrapper, so what you can do is you can also pass like this, right? Or if you don't want to pass like this, you can also pass the arguments also. Arguments means the argument that you will pass with the original function, right? Suppose your original function is, let me check, def what function I can create. Cube function we can create. Let's create cube, right? I'm creating a cube function same way. Okay, cube will take a num, right? It will return num a cube, right? Now I want to extend its functionality. Now what I will do is simple. Right now I am just writing a message print before function call, right? Before function call, and I am writing here print after function call, right? And in middle of this I will call the function. So how I can call the function? func. You can see here whatever argument we have given, we can use that function. We will pass the argument is num, right? You can also write here num instead of writing this, right? And it will return this result, right? Or you can say output. So I am saving this into output, right? Now I can print my output, right? Now I can print my output also here. Print cube comma output, right? So this is your function call. Here you can write before functionality, and here you can write after functionality, right? So this is now you need to return this function wrapper, right? So how you can return? You can return here, right? Return here, not inside this, outside this. Return wrapper. wrapper, right? Now it is returning. I'm running this, it will take some time. Now I have not written here at the rate, right? I have not written here at the rate. So what you can do is decorator. Sorry, why I have written generator? It should be decorator, right? Decorator sample, right? Okay, decorator equals to, I will create its object, right? Return wrapper does not match outer indentation. Okay, now it will match. There's a difference of one space, right? So I'm giving this name decorator demo. Okay, now you can create its object or just call this, right? Just call this. You will call this and pass cube, right? When you pass cube, now you can call this with argument. Suppose argument is 4. If I will run this, num is not defined. Okay, num is not defined. Okay, hey, here we need to pass num or we need to use the argument, otherwise it won't work like this, right? Otherwise what we can do is we can just copy this or pass this, right? Now it should work, right? You can see we are calling this decorator. First it is calling this function, this print, then it is calling the function cube is 64, then it is calling this, right? If you don't want to do all these things, the simplest way is, instead of this, you can define here at the rate decorator demo, right? Now I'm running this. Now I will just call the cube 3. You can see it is working as same, so you don't need to do these things. So this is a good way or good practice to use this. Okay, let's implement a real life example, right? The real life example means the example of execution time, right? I'm doing for same, right? Another, now I'm showing you real life application of that, calculate the time execution. What I want to do is calculate execution time, right? Execution time, right? So I'm creating a function execution time, right? And execution time I will pass again, I will pass a function and then I will again do a wrapper the same way. I'm giving this name wrapper because wrapper, or you can also say inner function, right? But wrapper is a good name which is generally used, mostly it is used args comma asterisk keyword arguments, right? Now what we can do is we need to import first here, right? Or let me import here, import time module. What it will does is I am calculating start time. Start time is, it will give me the start time, right? And I will also calculate the end time, right? End time equals to time. I will have both time. Between this I will call this function, right? Because I am passing here func, so I will call this and these are my arguments. I will pass this argument and I will get some result here or output, right? I will get the output and I will print the output, print cube, right? And output. Now after this I will print execution time, right? And here I will write end time minus start time. Difference of both the time will give us a execution time, right? And now I need to return this, return wrapper, right? Now this is my execution time decorator. Now what I will do is I will again pick this cube function I'm keeping here, I'm just keeping here at the rate this execution time, right? Now whenever I will call cube, it will, after execution, it will give me the execution time. Sorry, I need to pass here something. 7. Object is not, module object is not callable. Just a second, module object is not called. Okay, sorry. Time dot time. Okay, here also dot time. You can see execution time is 8.9 multiplied 10 to the power minus 0.5. So this is your execution time in seconds, right? So what we are doing is any function we can create, any function, right? Any function we can create, we can take any function here which we might have used or created at somewhere that we want to calculate here. Sorry, we don't have any specific function here. But if you create any specific function, it will give its execution time at the end of that, right? So this decorator has so many applications, especially in logging, testing, all these things you can see. Logging I will show you. In this advanced Python we also have logging. Logging is an important module in Python which is used to generate the logs. Without those logs you will not able to track the output or any error or any something where your program will fail, system will shut down, or some other issues you can trace via the logs, right? So that we will see. Right now we have done all the things with function approach. We can also do with the class approach. In this case you need to use the call method, right? So what we can do is, if you want to create the decorator using class, you need to define class and any name, right? Suppose in our case we are creating a cube decorator, right? So in cube decorator is your name of your class, right? So I'm keeping C capital, it is a good practice, and D small, right? Decorator, simple way, it will have again init method, right? So init will be here self comma function. Again the same way it is taking function, it will also take function, right? And self dot func is equals to func, right? And we also need to define one more function, underscore call underscore, and it will, you can write as self and args and keyword argument, right? Variable length argument and keyword argument. Here you can write the same logic that you have written here, right? Same logic that you have written here. I'm just copying here to just showcase you, right? The same logic you can write here. No need to do return. Here you need to return the output, not the function, right? Here you are returning the wrapper function. Here you can return your output, right? You can return your output. Let me run this and see. Yeah, until now no issues. Now what we can do is, let me create this cube method, right? I'm copying only cube. Now decorator will be your class name. What you can do is write cube, cube, C capital cube decorator. So if you run this now, self is not defined. Where? Okay, sorry, delf by mistake. It is delf self. Okay, it is okay. Now if I will call method cube, right? Cube of 25, right? Then you can see func is not defined. Where? Func, what is the line number? At output it is saying func is not defined. So okay, so we need to write here self.func, right? Self.func. Okay, try this again. Yeah, now you can see before function call, this is the output, and after function call, and it is returning this value again. So that is that returning value. If you don't want to return, then you can comment this. Right now you won't get this. output again, right? So this is how you can create the same logic you can write here. That's it. So this is your cube decorator. So via using class, so we have seen a decorator with function, with class. We've also seen one use case, right? There are other use case also, authorization and authentication. You can try and check. And for logging we will see in upcoming class. So that's it from my side in this. Now you can ask your question. I'm stopping the recording so that you can ask.